Alright, section 7.1 percents and fractions. First thing we want to look at is what a percent is. Now that you've seen this symbol, probably, it should be pretty familiar to you. You see it on commercials all the time. Percent off, APR, percent APR, percent discount, sales, all kinds of things like that. If we go back to the Latin of what percent means, cent is a word, a portion of a word that comes up a lot, and it means 100. And per actually means through, but we're going to think of percent as meaning per 100 or through 100. So technically it means per 100. And if we think of some common percent words, century, there's 100 years in a century. Cent, there's 100 cents in a dollar. Centennial, centipede, centimeter, different words like that all have the prefix cent, and they're all implying 100 of something. So here we're going to relate how percents are connected to fractions in this particular lesson. So writing percents, if we think back to like when you were probably learning how to count, you had those little tiny little yellow squares, and that represented 1. Then you would have like a stick, which would represent 10. They were broken into 10 little sections. And then you had like the real big ones, which would represent 100. And if you were lucky, you may have been in a class that had like the actual cube, which represented 1,000. We're going to be looking at the 100 because that's out a per 100, which is percent. So let's say we had 53%. Really what that means is 53 out of 100. So 53 of these, if I were to actually draw it off, 53 of these would be chosen if we were thinking of that area model. That's what per 100 means. So 53% is really saying 53 out of 100. So if I were to have x percent, that would be x out of 100. And that's all it is to it. So let's try example 1, writing the following percents in simplest form. So 29% is really 29 out of 100. And that's simplified. These are both relatively prime, so that's as far as it can go. 45%, 45 out of 100, which would reduce. We can divide both of them by 5. We get 9/20. 51%, 51 out of 100. That's in simplest form already because they're both relatively prime. 25% is 25 out of 100, which is 1/4. Sometimes you may read in a magazine like 25% of the people, and that's saying if they were to poll 100 people, 25 of them would have said this. So 100 is your base. That's what you're working from. It helps us keep things and put them in perspective as to what that really means. Obviously, 1% is a lot smaller than like 99%. It helps us kind of conceptualize what we're talking about then. All right, now the other way is writing these fractions as percents. So they're already fractions, we need to get them as percents. So we need to have denominators of 100, and I could, in this case, see mental math, multiply 10 times 10, and then 70 times 10, and I find that I get 70 out of 100, which is truly 70%. 3/5, I need my denominator to actually be 100 for it to be a percent. So 5 times 20 is 100, 3 times 20 is 60. I get 60%. 11 out of 20, multiply by 5, I get 55, so it's 55%. And then the last one is 4 out of 25, so I can multiply both by 4 to get my denominator to be 100, and I get 16 out of 100, which is truly 16%. Now, in all of these cases, they were pretty easy. We could just use mental math to figure out what they were. Let's say instead of b being 3/5, it would be 3/7. Well, if we want to turn that into a percentage, there's not something that we can multiply 7 by evenly to get 100. So in this case, we would have to go back to make a proportion, and from there we're pretty confident with our proportion solving skills. You could cross multiply, use the reciprocal. Either of those methods would work. We could here cross multiply. 7 times x is 7x, 3 times 100 is 300, divide by 7, and then you would find whatever value x is. And you're most likely going to have to round a little bit because it's not an even value, but that's okay. It'll get you the percentage rounded to 2 decimal places. In this box, we have some common percents to memorize and recognize. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They're just ones that are common, so it's good if you have them in the back of your mind. So 10%, going off of what we did before, is really 10/100. Cancel out the zeros, it's truly 1/10. 20% is 20 out of 100, cancel out the zeros. 2 out of 10 would simplify to 1/5. 30%, 30 out of 100, cancel out the zeros, 3/10. And you start to see a pattern here. This is 4/10, which is actually 2/5, 5/10, which is actually 1/2, 6/10, which is actually 3/5, 7/10 is already simplified as far as it can go, 8/10 can be reduced to 4/5, 9/10 is in simplest form, and 100% would be 100 over 100, which is just 1, and all those zeros cancel out. Okay, so those are some common ones that would benefit you to have memorized, because you'll see them a lot, and that way you don't have to do the changing over. Okay, a few more problems. Example 3 says a radio station randomly selects 1 of 5 finalists for a prize. You are one of the finalists. What's the probability that you will win? They want us to write our answer as a percent. So we just did probability. We want to know the probability that you're going to win. Well, there's 5 finalists. They're only going to choose 1, so it's 1/5. And we know now that that is 20%. If you didn't know that, again, you just turn it into fraction that has 100 as a denominator, times 20 times 20, 20%. Okay, but it's one of those ones we should have memorized. Example 3. You try, it says an example, an airport security screener searches the luggage brought to the ticket counter by 3 of every 10 passengers. If you're one of the persons in a group of 10 passengers, what's the probability you'll be chosen to have your luggage searched? Write your answer again as a percent. So the probability that you are searched is going to be 3 out of 10, which is 30%. So you have a 30% chance of actually being searched. We can see here that percents also relate a lot to probability. Example 4. A desert tortoise can go a year or more without drinking water. When it does drink, its body weight can increase by 40%. Suppose a desert tortoise weighs 15 pounds after a long period without water. How many pounds can a tortoise gain when it drinks? Well, really, what we want to know here is what is 40% of 15 is what we're trying to figure out. So 40% is 40 over 100. Of, if you remember back, is actually another way of saying multiplication in 15. So really here we can do 40 over 100 times 15 over 1. This can reduce. We know that it's 2/5. So 2/5 times 15 over 1 cancel out. We don't even need a calculator. We find that this tortoise can gain 6 pounds after it's drank water after a long period of time. Interesting stuff. Practice. It says 90% of the flights that left a certain airport yesterday departed on time. If there were 150 flights from the airport, how many departed on time? So we want to know what is 90% of 150. 90% is really 9 over 10 times 150 over 1. Cancel out. We're going to get 9 times 15, which is a total of 135 flights. Okay? Now these ones I'm just going to set them up, but you're going to do them in the exact same way. They just don't have the word problem that accompanies them. Write the percent of the numbers. So 25% of 36 is 25 over 100 times 36. And we could write that as 1/4 times 36 over 1. And then you solve it. The setup for letter C, 70%, 70 over 100, or 7 over 10, times is what of means, 70. We can put that over 1. Cross cancel, solve. And in letter D, 50% of 14. 50% is 50 over 100, and then of means multiply, 14. And you can see here that that's going to simplify. We know that that's actually 1/2. So 1/2 times 14 over 1, and you're going to get your answer and solve it there. Okay? If we go back, just in case you did do these, to double check your answer, for the first one, you're going to get 9. For the second one, 1 and 7, you're going to get 49. And for the third one, you're going to get 7. Okay? Great job, guys. See you later.